Operators are widely used in many programming languages. They are arithmetic operators, relational operators, logical operators, assignment operators, increment and decrement operators, bitwise operators, and special operators. I'll show you what operators are. Like addition operation is nothing but like 2 plus 4. Here 2 is an operand and 4 is an operand, and operator is plus addition symbol between two operands, and similarly I'll show you one, like I'll use here directly 2 plus 3. See, I got 5. And similarly subtraction, like 2 minus 2, I got 0. And multiplication, for multiplication 2 star and 4 2s are 8, and you got 8. And for the division operator, 2 like 10 divided by 2. As you can see here, the value I received is float. In Python we have one more advantage, is that we have float division. Is nothing but in the sense of 10 divide double slash by 2 will result as an integer value, is nothing but 5. For example, I'll write one more thing, like 5 by 2, you know that we'll get 2.5. It is float value, but if I write float division, I'll get an integer value. Hope you guys understood. And one more useful operator is power function. We can write like this, pow, but without writing like power function, like pow of, and base is 2 and exponent is like 3, is nothing but 2 power 3. And if I print like 2 power 3 is 8. And I can write power function in another way, like 2 double stars is nothing but 2 asterisk and an exponent value, mean power value. 2 cap 3 is 8. And these are the operators in Python. And in Python we don't have direct increment operations like other programming languages have, like a plus plus or b plus plus. I'll show an example. For suppose a equal to 1, if I type a plus plus, I'll save the program. If I run the program, it throws an error because invalid syntax. We don't have a plus plus, or we don't have pre-increment or post-increment directly. We need to write like a equal to a plus 1 or a plus equal to 1. These are the only two ways to perform increment operation or decrement operation. Like for decrement we need to write a minus 1 or a equal to a minus 1. These are the only two ways to perform post increment or pre increment or decrement of a value. And we can get directly a boolean value, like is 1 greater than 2 false, like minus 10 greater than 5 false. And we can compare the strings also, like hello equals to hello, so it's true. But if we write like hello equals capital H here, it says false, because it will consider this as another string and this is as another string. And 2 not equal to 2, true, and 2 not equal to 44, sorry, true, sorry, not in the sense of negation of the true value. Here 2 equal to 2, negation in sense false. And we can use logical operators directly, like A or B. A or B in the sense of, for example, let's consider x is a true and y is a false. A or B means x or y is true, and for AND gate x and y is false. And similarly we can perform not gate or XOR functions. Sorry. Similarly we can perform not, like not x in the sense of false. And let's try bitwise operators, like 5 left shift of 4. 5 left shift of 4 in the sense of will result 80. See, that's 80. And for right shift we'll use 11. Right shift of 1 will get 5. Sorry, if we give 1 greater than, it will check whether it's true or false. We need to write 2 greater than operation. we need to write 2 greater than symbols to perform bitwise operators. Right shift, we need to write 2 greater than symbols in order to perform bitwise operators. 11 right shift of 1 in the sense of we'll get 5. And similarly we can perform bitwise AND operation, like 5 and 3 in the sense we'll get 1. And similarly 5 or 3 will get 7. And bitwise XOR, we can perform XOR by using 5 cap 3, we'll get 6. That's it. And we can perform bitwise invert. Like see, so you got -6. See, if write negation, write negation 4 will get x plus 1 is nothing but 4 plus 1 is 5, and negation 5 minus 5. And now let's see how operator evaluation takes place. I'll write an equation like expression 2 minus 4 into something like 2 or 214 will get something like 48. But this operation will takes from left to right using Bodmas rule. First precedence will be given to the division operator and star operator, and followed by addition and subtraction. And Now let's see some type conversions. Like a is 5. This is integer type of a. We need to convert this integer to string. In order to do that, we have a function called str, and str of variable. In the sense, we'll get string. And similarly, to convert string to float, we have float of a. As you can see, I got 5.4. And that's it for the video. And in the next video, we'll see about data structures. Before ending the video, I want to show you a few things like integer of a, whether it's equal to a string, string variable of 2 or not. Integer 2, whether it's equal to string variable of 2 or not, it will return false because they both belongs to different classes, mean different data types. And similarly, if you want to know like how this XOR and if anyone don't know how these left shift and right shift operations will take place, and I'll show an example. Wait, ideally I'll remove this. I'll first write 4 left shift of 1 is nothing but binary conversion of 4 is the binary conversion of 4 is 4 equal to 1 0 0, and left shift of 1 is nothing but this one will move one left side, means for suppose we'll consider this. Here we have a 0, and while doing left shift we'll have the resultant will be like 1 triple zeros, which is nothing but binary of 1000 is 8. I'll run program here like 4 left shift 1 is 8, and similarly right shift 4 right shift 1 is nothing but 4 0 1 00 is the binary representation of 4, and right shift of 1 means shifting 1 towards right is nothing but 0 0 1 0 is nothing but value of 2, and 4 right shift of 1 is 2. And I'll show you one more useful thing, like in order to convert a binary, in order to convert an integer to binary, we have an inbuilt function called bin, is nothing but binary, which takes an input integer 2. It takes an input integer and returns the binary value. Binary of 2 is 1 0, binary of 4 is 100, and similarly not only binary, we can convert like for converting binary to integer, let's like this. For example, I have 10. For example, if you write int of 10, it will consider 10 as an integer value. But if you write like, if you give one more parameter comma 2, it will consider this as an binary data type. This is base value. 10 base 2 is nothing but base 2 value means binary. 10 base 2 is nothing but resultant 2. Cannot convert non-string explicitly. Sorry, we cannot give integer value, so 10 comma 2 is nothing but 2. And similarly integer of like binary value of 0, something like 0 blah blah blah, and comma 2 is not, it will result as a decimal value of that binary representation. And similarly we can convert integer to hexadecimal value like 10, it will result in A. And for converting in character to ASCII value, we have ORD of character, in the sense it will return the ASCII value. And to get back the character value, chr is a function. Chr of the ASCII value will return the character. Is that the C? And that's it. In the next video, we'll see about data structures.